and welcome to our first in this series of videos on the algebra and functions part of the specification, and we're going to be taking a look at indices and surds. These are skills that they are examined in their own right, but they appear in so many different areas later on throughout the course in other topics, so you need to be absolutely spot on with these building blocks for your algebra skills. So let's have a little look at what we're going to do. So by the end of the series, you will be able to know and apply all your rules of indices. You'll be able to work with surds and simplify surds to their simplest form. Use surds with all the four operations, by which I mean addition, subtraction, multiplication, division. With regard to division, you'll also know that division is actually done by something what we call rationalizing the denominator, and you'll be able to use the difference of two squares to allow you to be able to do that in certain situations. So in this video we're going to have a look at your laws of indices, and to begin with we are just going to focus on integer powers and not worry about the fractional and negative indices. We'll look at those in a separate video. So here we go. Laws of indices. All of this content is technically on the GCSE syllabus, and so is presumed knowledge for the A-level course. So we're going to quickly run through these because all of this content is stuff that you will have seen previously if you studied GCSE. So, basic laws. First of all, your addition law. So when you're multiplying, you add the powers. Law 2 is our division law. So when you're dividing, you subtract the powers. Law 3, the zero index, so we're saying that anything to the power of 0 is 1. Law 4, now I split these into two because we've got a couple of laws regarding brackets. The first one is if you've got a power inside and a power outside the bracket, then you're going to be multiplying those powers together. The second one of those is that if you've got two terms within the bracket, for example we've got there a times b all to the power x, then the power applies to both bits. And that's particularly relevant, as you can see there, with regard to fractions as well. So the power applies to all elements inside the bracket. And then we're going to get on to our negative laws, which is the fact that a negative index is reciprocal, or 1 over. And in the case of fraction, that just flips it upside down. Notice there that negative index, for example, we've got a over b to the power minus x, it flips it upside down, and so the power becomes positive. And finally, your laws on fractional indices, and we know, or we should know from GCSE, that fractional indices are roots, and the denominator in a fraction is the root, and the numerator is a power. Okay, so all we're going to do now is just look at a range of examples just involving all those different laws, just to get you familiar with those, and then it's just a case of lots of practice just to make sure you're entirely happy with all of that. So let's take a look at some examples. In each of these cases, the way to deal with these is to deal with the coefficients first and then deal with the variables. So deal with the number part first. In our first example we'll deal with the numbers. That's 3 times 5, which is 15, and then we've got x squared times by x to the power 6. It's a simple example of the addition law. So that's going to be x to the power of 8. In our second example, we've got a division going on, but we're going to have to be a little bit careful because, as you can see, we've got a minus power on the bottom, so we're going to have to think carefully about that when we come to deal with it. Let's first of all, though, deal with the coefficients. So I've got 14 over 35, so I'm just going to treat that as if that was just a fraction. 14 over 35, that can be simplified. Divide top and bottom by 7, and you've got 2/5. Now we've got to think about our division law, and our division law says that when you divide, you subtract the powers. So the powers I've got are 2 and minus 4. I've got to do 2 minus minus 4. That's the bit where we've got to be a bit careful. As you can see, 2 minus minus 4 is power 6. So I've got 2x to the 6 over 5, or 2/5 x to the power 6. Example C. So we've got numbers in here, we've got 3 different variables, we've got powers inside the bracket, we've got powers outside the bracket, so there's a lot to sort out. So using our bracket laws, remember we had 2 laws, one that said that the power outside the bracket applies to everything inside the bracket, and the second one that said that when you're multiplying powers inside and outside the bracket, you're going to be multiplying. So let's deal with the coefficient first, which is the 3. The power applies to 3 as well, so that's 3 cubed, so that's going to give us 27. Let's deal with the x's, so we've got x to the power 4 all to the power 3, so our law there says that we're going to multiply, giving us x to the power 12. Y, that's effectively y to the power 1, so y to the power 1 all cubed, 1 times 3 is 3, and then we've got z to the minus 2 cubed, so that would be z to the minus 6. So dealing with them each bit separate, one at a time, using all our power laws. And there we go. And finally part D. Now that looks like a whole mess of stuff going on there, so we've got some tidying up to do first, and then we can do some simplifying afterwards. So the things to tidy up to begin with would be the bracketed bits on the top and the bottom. So from that first section we've got 2x squared y cubed, all squared. So let's deal with that bit first. You can see 2 squared is 4, x squared all squared is x to the power 4, and we've got a y to the power 6. That's 6xy. I'm just going to leave that as it is for now. We can't do anything more with that, but we'll tidy that up in the next step. And on the bottom we've got 5x cubed y to the power 6. I'm going to leave that as it is. And then the bracketed bit clearly is going to become 27x cubed y cubed. Now on the top we'll do a bit of tidying up again, so let's deal with the coefficients. So I've got 4 times 6, which is 24. X to the 4 times x is x to the power 5, y to the 6 times by y, y to the 7. And on the bottom we've got 135 x to the power 6, y to the power 9. All that remains to be done now is just some tidying up, same as we did in example B. So we've got 24 over 135. Comes 8 over 45, x to the 5 over x to the 6, it's just going to leave us with, we could write that as x to the minus 1, or I could put that as an x on the bottom, and then y to the power 7 divided by y to the power 9, again that could be y to the power 2, or alternatively y squared on the bottom of the fraction. Either way, if you wrote that using negative powers, that would still be correct, that's absolutely fine, so there's often more than one way to write an answer. The other thing to note with this one is that it might have been that you wanted to do a bit of simplifying earlier on. So what we could have done up here was kind of do some dividing with the 3's here. And you could have kind of done a bit of cancelling out earlier on with your x's and y's if you wanted to. But either way, whichever one you prefer, you would still end up with the same answer. So let's now look at a kind of different kind of example. And these are the type of things where you might see them as questions on the examination paper, asking you to kind of think about how you might manipulate your powers and expressions, and in some cases solve equations involving powers. So here we go with the first one. First thing we know is that 27 is 3 to the power 3. So we've got to state this in the form of 3 to the power y, so getting that 27 written as a power of 3 would always going to be your first step. And so now that 27 to the power 2x plus 3 can be written as 3 cubed to the power of 2x plus 3. Now using our bracket law, we know that we multiply the power inside and outside the bracket, so we've got that. So we've now got it in the form 3 to the power something, where that something in the question, that is the y, that's now 6x plus 9. So it says stating y in terms of x, so we can just say that y is 6x plus 9, and that's what is required from the question. In the second example, we've got similar technique, but we're going to use a slightly different idea to get to a result here. Here we're actually being asked to find the value of x. So we're going to start off by expressing each term as a power of 2. And I know I'm going to do that because in each case I've got 2, 4, 8, all powers of 2. You have to look at the numbers that you've got there as the basis for your powers and decide which is your smallest number that you're going to use. So for example, if I had 3 9s and 27, I'd be using powers of 3. 5s, 25, 125, and so on, I'd be using powers of 5. So you've just got to look at the question and decide what's the appropriate value to use. So we've got 2 to the power x, 4 to the power x plus 1 is going to be 2 squared to the power x plus 1, and 8 is 2 cubed. What we're going to do now is take the left-hand side of our equation and just tidy it up. So we're going to do the tidying up here first of all. So I've got 2 to the power x times by 2 to the 2x plus 1. That bit there comes from our multiplication law. And again, now I can use the addition law on this whole thing. So I've got to add the powers. So I've got x plus 2x plus 2. So that's going to give me 3x plus 2 as my power. Now, the key to this one is to say that, well, we know that this bit on the left-hand side here has exactly the same value as the bit on the right-hand side. And so that can only happen if the power here, 3x plus 2, is the same as the power here, power 3. So we can say that 3x plus 2 has got to be equal to 3. And now all of a sudden what we've done is created a simple equation that we can solve in terms of x. And to solve that, you can see move the 2 over, divide by 3. You end up with x equals 1/3. And there is our equation. It said solve, so we needed to work out a value for x. The final set of examples we're going to look at are how you can use your power laws within other manipulations of the polynomials, and particularly this kind of thing pops up, particularly when we start doing your calculus later on, particularly part C. So let's just have a look at what's going to happen here. So first one, simply got to multiply out. I've got x squared times by x cubed, so that's going to give me x to the power 5. There we go. And then I've got 3x squared times by 3y, so that's going to give me 9x squared y. In part B, the key with this one is we've got to do some multiplying out of the brackets. So there's my 4x minus. I've very carefully included the minus. And so we've got to multiply out the brackets. Often what I like to just come over to the right side, do a bit of working out first. So over here, what I'm going to do is just work out what that thing is going to be before I then come back to my main working and plug it in. So let's just kind of do the multiplying out. We've got x squared times x squared, x to the power 4, minus 5x times x squared, minus 5x squared. There's another minus 5x squared there, and then the plus 25. So I've done a little bit of working out, a bit of thinking over on my right hand side. So I'm going to come back to my main equation now, and it's absolutely vital that I'm thinking carefully about that minus sign. So we've got 4x minus x to the power 4 minus 10x squared plus 25. And so now think about what's going to happen with the minus. We're going to put these in, and generally speaking we like to put in kind of the higher order powers first. So I'm going to put in the x to the power 4 term first. That's going to be minus x to the power 4. Then I've got my squared term, and that one's a positive because I've got a minus times a minus. Then I've got the 4x, and finally minus 25. There it is, and there's my solution. And the last one, we've got to do some multiplying out those brackets on the top first of all. So again, I'm going to jump out to the right side of my page, just do a bit of working out first. So there it is when it's multiplied out, and so that's what I'm going to put in there. And then we've got to divide by x squared. So what we're going to say now is each individual term has got to be divided by that x squared term. So what I'm going to do is take my x to the power 4 divided by x squared, do the subtraction of the powers. That's going to give me 2x squared. Here we've got x cubed divided by x squared, give me x to the power 1, or just the 3x. Now I've got 2 over x, so 2x divided by x squared, and in this case I'm going to write that as a negative power, so x divided by x squared, x to the power minus 1. And now I've got 3 divided by x squared, so that would be x to the power of minus 2.